Look up tonight. Every single star you can see is already dying. And a few of them go out in ways that sound completely made up. One kind of star is so massive that when it goes, it leaves no black hole, no neutron star, not even a smear of wreckage. It just erases itself from the universe. Every star runs the same countdown, including the one keeping you alive right now. Tonight we climb every way a star can die, to find out exactly how the sun's clock runs out. Death by exhaustion. Way less than about 8 times the sun, and a star doesn't explode. It just runs out of fuel and fades into silence. First it swells into a red giant, then puffs its outer layers into space in slow, glowing shells. What's left behind is a small, exposed stellar core. That leftover ember is a white dwarf, held up not by fusion, but by quantum pressure between electrons packed as tightly as physics allows. Squeeze our entire sun down to Earth size, and you get a white dwarf. A teaspoon of it would weigh several tons, and it'll cool for far longer than the universe has existed. White dwarfs stay calm and quiet, right up until they start stealing mass from a companion star nearby. Pile on enough stolen mass, and the white dwarf crosses a hard limit. Its core ignites all at once in a runaway thermonuclear chain reaction. This is a Type I supernova. For a few weeks, it can outshine every other star in its host galaxy combined, then leave nothing solid behind at all. That's a white dwarf going out with a bang. Now imagine a star more than 8 times heavier, one that never stops fusing until it's fatal. Massive stars fuse hydrogen to helium, helium to carbon, all the way up to iron, and iron is where the party stops. Fusing iron costs energy instead of releasing it. The core can no longer push back against gravity, and in under a second, it collapses. That collapse triggers a rebound shockwave that rips through the outer layers and blasts them into space at tens of thousands of kilometers per second. A core collapse supernova. Unlike the white dwarf's total annihilation, this leaves something behind. A crushed core about 20 kilometers wide, made almost entirely of neutrons. Almost all the explosion's energy escapes as neutrinos, particles so shy they pass through the collapsing star, through Earth, and through you, without you ever noticing. A neutron star packs more mass than our sun into a sphere about 20 kilometers wide, roughly the size of a small city. A sugar cube of it would weigh roughly 1 billion tons. Some neutron stars do something even stranger. They spin, blast twin beams of radiation from their poles, and sweep them across the sky like a lighthouse. These are pulsars, and some spin more than 700 times every second, fast enough that a few genuinely spin faster than a kitchen blender. From Earth, we don't see a rotating star. We see rapid, precise flashes, some more reliable than an atomic clock. Remember that crushing density from a normal neutron star? Some neutron stars take it further, wrapping themselves in the strongest magnetic fields in the universe. A magnetar's field is so intense that, in theory, it could scramble a credit card's magnetic stripe from about halfway to the moon. Every so often, a magnetar's crust cracks under its own magnetic stress. The biggest starquake ever recorded unleashed more energy in 1/5 of a second than the sun radiates in 250,000 years. Neutron stars and magnetars are the survivors. Push a dying star's core past about 20 times the sun's mass, and even neutrons can't hold the line. Gravity wins completely. The core collapses past every known form of matter into a black hole, a point where our physics simply stops giving answers. Cross its event horizon and there's no coming back. Not because you're moving too slowly, but because every path forward, even at light speed, leads only deeper in. Get too close before you even reach the horizon, and tidal forces stretch you into a thread of atoms. Astronomers actually call this spaghettification. A basic black hole forming quietly is already unsettling. Some collapsing stars manage something worse. They punch 2 jets of radiation straight through themselves. This is a gamma ray burst. If one ever fired straight at us from a few thousand light years away, scientists think it could strip away enough of Earth's ozone to trigger a mass extinction. So remember that plain black hole from a minute ago? A gamma ray burst is what happens when that same collapse points a loaded gun at the galaxy. And now, the one that started this whole video. Stars over about 130 solar masses die in a way that shouldn't be possible. Inside a star this massive, the core gets so hot that gamma rays start converting into matter and antimatter pairs, and the pressure holding the star up suddenly collapses instead. That sudden loss of pressure triggers runaway oxygen fusion, so violent, it tears the entire star apart in one single, uninterrupted explosion. No core survives to collapse into anything. No black hole, no neutron star. The star simply unbinds itself completely, scattering every atom it ever made. For decades, this was just a theory. Astronomers now think they've actually caught a few of these total annihilation explosions happening in real galaxies. Zoom out, and every single ending on this list is exactly the same fight. Gravity is always pulling in. Fusion, degeneracy pressure, whatever a star has left, is always pushing back out. Every quiet fade, every supernova, every black hole is just gravity finally winning. The only question is how hard and how fast. So the star that seems to break physics doesn't, really. It just runs out of ways to fight back faster than gravity can be stopped, and takes the entire star down with it. As for the sun, it's far too light for any of the violent options. In about 5 billion years, it'll swell, shed its outer layers, and quietly become a white dwarf, exactly like Category 1. Every massive star supernova leaves behind a black hole or neutron star. Some leave absolutely nothing behind at all. Here's the part that should change how you see the night sky. None of this destruction is wasted. Every heavy element past iron, the gold in your jewelry, the iodine in your thyroid, most of the silver on this planet, was forged in one of these deaths. You are, quite literally, made of dead stars, assembled from the wreckage of explosions that happened long before the sun ever existed. So next time you look up, you're not just looking at stars, you're looking at future raw material mid-transformation. Every ending on this list, from the quiet fade to the star that erases itself completely, is also somebody's beginning. We've covered how a single star dies. Next time, we're covering what happens when two dead stellar corpses collide. That collision forges gold, platinum, and a ripple in space-time itself. Subscribe so you don't miss it.